Sai, good to see you. So for people who don't know you, can you just tell us really quickly about who you are, your role, and where you work?
Hey Bart, yep, my name is Sai Vennam. I'm a principal solutions architect at AWS. I'm a container specialist, essentially means I focus on container-based solutions here at AWS. So primarily Kubernetes. I've been with the Kubernetes journey for, I think, close to a decade now. And since then, I've seen Kubernetes go through so many different transformations. So excited to get into it today and talk a little bit more about Kubernetes and AI.
And speaking of Kubernetes, what are three Kubernetes emerging tools that you're keeping an eye on?
One thing that I think we'll talk about more today is how Kubernetes really has, it started as an orchestrator, but its capabilities in orchestration have really grown. And so one of those, let's say Karpenter. It's an open source project developed by Amazon, contributed to the CNCF. And Karpenter has really evolved the approach that customers are taking with selecting instances to run workloads on Kubernetes. So that's one. Another on theme for today's episode is any sort of purpose-built open source project around orchestrating AI ML workloads. So the ones that come to mind are things like Kubeflow and Ray. Right now, we see a lot of usage of these types of projects because they are purpose-built and they can help solve things like training models or inference with models. So I think that's another interesting one. A third one, so an interesting project that I've seen recently is called Kwok. I think it's Kubernetes without kubelet. Essentially allows developers, ops teams to simulate Kubernetes clusters with thousands of nodes without actually having the nodes, which is kind of perfect for the type of workloads that we're seeing customers scale up on Kubernetes. Thousands of nodes. You can imagine, of course, training models. So that's an interesting one to keep an eye on.
Since you mentioned models, we want to look at a couple of questions more in detail here. As models get larger and more complex, is Kubernetes still the right orchestration platform, or do we need something fundamentally different?
This is a great question, and I think that the challenge here is maybe people think, well, there's this brand new use case coming in, so we need a brand new orchestrator. But the fact is, Kubernetes has been around for quite some time now, and I think the magic of the way it was built, the open source foundation, the extensibility of it, means that it doesn't necessarily phase out. In fact, it matures into the new requirements. So especially with AI, ML, I think the requirements are really aligned with the fundamentals of where Kubernetes excels. Essentially node instance selection, orchestration, managing maybe long running workloads like training, or even workloads that need to be fired up in response to demand, like chatbot use cases with inferencing, where you might have a lot more traffic in a couple of hours of the day rather than some other hours. So these are all the kind of things that Kubernetes lends itself well into, and I think because of that, we're going to see Kubernetes scale and grow into the use case rather than being replaced. Although I am excited to see some purpose-built AI solutions running on top of Kubernetes. Excited to see what people come up with.
What are the unique challenges of autoscaling for AI workloads compared to traditional web applications?
Yeah, this is a really interesting challenge. And it's also the reason why we're seeing so many flock to Kubernetes, whether it's for training models or running inference workloads. And I want to focus more on the latter here of inferencing, because I think there's a few different aspects that are critical here that make customers realize, we need to think about how we scale in response to load. So for one, I'll say, it's not just spinning up another x86 instance to scale your workload into. With AI, there's a lot of different type of workloads that some require GPUs. Of course, on AWS, we have our optimized compute, like our accelerated compute for things like training and inferencing, called Trainium and Inferentia. It's pretty easy to remember. But essentially, you want an orchestrator, a platform like Kubernetes, to be able to not only scale in response to load. And of course, any cloud provider like AWS is going to be able to provide you that scale. But you also want to select the right type of instances to run those workloads. You don't want your CI/CD workloads running on NVIDIA GPUs. That's not the right cost, price, performance that you want. And you definitely want your inferencing and training workloads to leverage GPU compute, because time is critical, and those instances are catered for those type of workloads. So these are the type of challenges that come up, and the solution really is leveraging something like Karpenter, a cluster autoscaler, which is going to make that node instance selection more straightforward. It's going to let you decide which workloads run on which instances, of course, with affinities, taints, tolerations, all of those good Kubernetes constructs. These are all the type of things that you'll need to consider with autoscaling in Kubernetes for AI workloads.
And how do organizations determine the right balance between CPU, GPU, and specialized AI accelerators for their Gen AI workloads?
I think this really starts with having a strong operations team, a solid set of SREs and platform engineers that can understand and delineate the different type of workloads. There's, of course, going to be the CPU-heavy workloads. These are things like simple API processing or CI/CD type of workloads. These are, honestly, I'll call them undifferentiated, because basically every Kubernetes-related project is going to have them. These kind of workloads run on the most efficient compute possible, right? x86 instances, ARM-based processors like Graviton on AWS. Use Spot instances for better price when possible. And then you get into some of the more advanced workloads, right? So training and inferencing. Here's where you'll want to leverage the best price performance instances, not necessarily the cheapest, but the ones that get the job done with the best performance. And so, of course, you can use NVIDIA GPUs on AWS. These are things that you can select with Karpenter, of course, our cluster autoscaler. You can tell it which workloads require which type of instances. So whether it's NVIDIA or whether it's an Inferentia or Trainium type instances that we talked about earlier, these are things you can configure. So I did mention that ops is critical here. So one of the things you can leverage is something like Amazon EKS Auto Mode, a new capability that we released on AWS. It's essentially going to take care of that operations layer for you, make things like keeping your clusters patched and secure automatically, keeping them upgraded more easily, and helping you manage various components in the cluster. Things like Karpenter, maybe the CNI, the kube proxy, all of these components that are in every Kubernetes cluster, Auto Mode will handle for you. And then you can really focus on what really matters, right? Like training, serving, AI workloads, focusing on that innovation. I think that's a critical thing to consider.
And Kubernetes turned 10 years old last year. What should we expect in the next 10 years to come?
The next 10 years, I think we're going to start to see cloud providers, especially AWS is already doing this, really spending more time in the data plane of where customers run workloads. And also, we spent a lot of time on the control plane. We continue to optimize it. We just released the capability to run 100,000 node EKS clusters for massive training jobs, which, by the way, I think upstream Kubernetes recommends 5,000. So these are the kind of things that I'm seeing if we're optimizing the control plane of the number of nodes you can run, how well those run, like optimizing the etcd and that kind of thing. But more interestingly, in the next 10 years, I think we're going to start to see purpose-built platforms running on Kubernetes. Think things like Ray or Kubeflow, these orchestration or workflow engines, purpose-built for AI workloads. So in a lot of ways, I think we're going to realize that we're going to have innovators using Kubernetes without even realizing it's Kubernetes underneath the covers, which is really interesting.
What's next for you, Sai?
For me, I'm diving deep into more orchestration use cases around AI. I think this is like the emerging space. It's exciting. We're seeing kind of this revolution of the same type of things that customers needed from Kubernetes 10 years ago, but at a whole different scale. So it's a lot of fun that it's kind of familiar, but also a brand new space, a brand new use case. So I'm going to be diving deeper. I love creating content and videos to help folks understand Kubernetes. I've been doing it on YouTube for a while. So I think I'm going to start doing more of that, especially as, there's so many more people trying to learn more about this space. So that's what's important to me.
Sounds like a plan. Sounds like you got plenty of work to do there. And if people want to get in touch with you, what's the best way to do that?
I think LinkedIn is probably the best place to start. I'm fairly responsive there, so reach out, find me on LinkedIn, Sai Vennam, and we'll talk there.
Perfect. Sai, thanks so much for your time today. Look forward to speaking to you soon. Take care.
Thank you.